All right, I think we can go ahead and get started. Again, good morning, good afternoon, good evening. Thank you guys so much for joining. We're really excited to be talking to you today about a subject in the conversational world that has really been expanding and seeing significant increased investment from brands all over the globe, both over the last few years, but especially during these challenging times that we're all faced with. And that's call center modernization with modern interactive voice agents. But before we dive in, let's set the stage. My name is Emerson Sklar, and I'm the Chief Evangelist of Bespoken. And I'm joined here today by Maddie Mantha, NLP Evangelist at Rasa. To give a little overview of today's webinar, we want to make sure that we can give you the tools and insight that you need to create perfectly optimized modern IVR systems with an eye towards increasing your customer satisfaction, increasing call deflection rates, and reducing overhead and cost. We're going to start out by taking a look at the historical landscape of the call center world, dive into how you should be thinking about success and what techniques you can apply to ensure that you achieve it, and wrap up with some expert input from the folks at Rasa about how to leverage these techniques in a mature, conversation-driven development lifecycle. Now, to give you a bit of a background on Bespoken, we're the leaders of voice automation, and we're used by some of the world's largest brands to perfect their voice-enabled products. We give your jaws a rest and help you deliver stellar conversational products, all without ever having to talk to a virtual agent on a phone or a smart speaker. And we have a comprehensive suite of solutions that really are designed to address different challenges within the voice world. We enable automated testing, which gives your business confidence that your products are working as designed while lightening the load of your QA team, also simultaneously broadly increasing their reach and scale. We enable automated trading of your voice products, ensuring that your users are properly and accurately understood every single time they speak to it, regardless of their accent, gender, or background noise. And we enable continuous monitoring, letting you sleep easy at night, knowing that your apps are continuing to perform flawlessly over time and notifying you immediately should anything change. And we do this for nearly any platform under the sun. We like to say that if you can talk to it, we can test it. And whether it's via a virtual device for some of the larger and more open players in the space, or if it's via physical devices for some of the closed ecosystems or for some interesting, unique use cases, we have a solution that fits any of the needs that your conversational team might have. Now, I mentioned that at the beginning that we've seen extraordinary growth in the IVR market. And some of the reason behind that is pretty obvious. With everyone spending more and more time at home nowadays, they're both placing more calls in to customer service teams, and with the stress of the current climate and the increases in the number of such calls that people are placing, they're showing less and less tolerance for poor IVR experiences. But I think it's important to understand the evolution of the call center world to really understand how we got to this point today and where we can go in the future. In the mid-1950s, we saw the rise of the progenitor of what we would consider now to be IVRs, and that was automated call distributors. Before this point, call centers relied heavily on manual telephone switchboard operators to route calls to an available human agent. So with the introduction of these ACDs, even though they were still fairly rudimentary, these calls could be routed to specific available human agents based on very, very rudimentary things like telephone numbers, times of day. Dialing into call centers, though, was still very, very expensive for individual consumers at that time. And so nearly a decade later, when 1-800 numbers were introduced, we saw brands trying to find a way to better support their individual users and reduce some of the friction that they might have had previously that would prevent these users from seamlessly interacting with their brands. In the 1970s and into the 1980s, we began to see these systems move away from just one-way interaction and began to see them be more interactive. Most of that interaction was done via touch tones, via DTMF. But in the 80s, with the advent of the digital call center, moving into the 90s, moving largely away from the purely analog and telephony-based system, we saw them becoming digitized. And so we also then saw some increased sophistication in speech recognition. No longer were these vocabularies that somebody could use to interact so extremely limited. People could start speaking in a more conversational nature. In the 2000s, with the explosion of the internet, call centers finally had a way to decouple their teams entirely from the plain old telephone system and provide much more scalable and much faster support to their customers. But it really wasn't until the last decade that we saw a generational shift. As with many other technologies, organizations have found that they can provide infinitely scalable, low cost, and highly effective solutions by embracing hosted cloud technology. Each of these shifts, I guess to bring it home, each of these shifts has been driven by advances in computing power and technology, certainly. But the adoption of them by the world's largest brands has been driven more specifically by a desire to reduce cost and reduce friction in the customer experience. Similar to the evolution of IVRs, we've seen prolific growth in the modern voice assistant world. Twilio, one of the most powerful modern cloud communication platforms, was established in 2008, long before sort of the current wave of smart assistants had been born. While not a telephony system per se, the first and most popular of the modern voice assistants, Siri, was released nearly a decade ago, in 2011. Hard to imagine that it was that long. There was a lull for a few years, but in the mid 2010s, we saw huge growth. IBM Watson, Amazon Alexa in 2014. Cortana and Google Home in 2015, Google Assistant and our webinar partner Rasa shortly thereafter in 2016. And since then, there's still been considerable growth, but it really wasn't until the past year that we've seen many of the big players getting into the space specific to the customer communication world. The last year alone, three of the biggest organizations. Amazon with Amazon Connect, Microsoft with Azure Communication Services, Google with the Contact Center AI, all came to market with very, very compelling options to further streamline interaction with their customers. And so with their entry, it's clearer now more than ever that modern interactive virtual assistants are here to stay, and that really is at the heart of today's contact center modernization efforts. So what does that look like, though? Well, modern IVRs run on artificial intelligence. And a modern IVR today is comprised of a few different pieces. You have a telephony gateway, some way for people to receive or place calls to this system. You have a mechanism for ASR, automated speech recognition. You have an NLU, natural language understanding engine, which provides the capability for handling and making sense of potentially complex user dialogues. And then ultimately you have some kind of service which provides the fulfillment logic, provides the actual brains based on the output of the ASR and NLU that you have. And there are platforms out there that try to provide an all-in-one solution. But what we've pictured here with Rasa providing NLU capabilities to support Twilio or perhaps other telephony and ASR systems really is a best-in-breed architecture for the modern IVR space. And so why are we so keen on Rasa? Well, Maddie's going to tell us a lot about some of the specifics of what Rasa is capable. But for us, there really are a few tremendous benefits that we see and that our customers see as well. First is that with the all-in-one solution, you're really locked into that ecosystem, and people really don't like vendor lock. Those solutions are often very, very expensive. They're often quite inflexible. And they really provide very few levers for you to be able to really own and customize that end-to-end experience. And that's a huge differentiator with Rasa. It's extremely cost-effective. It provides capabilities that at worst are on par, and from some of the research that we've done, often very significantly exceed even the heaviest hitters in the space. And it's also very, very easy to implement and allows for extremely deep and very, very powerful control over its behavior. And so that combination makes sure that you never hit a brick wall in your voice development, makes it really a truly unique fit for enterprises looking to tackle a modernization effort. Now, I want to come back to the motivating factors behind why a lot of brands and companies are taking on these initiatives. IVR modernization's typically focused on three things. reducing cost, increasing throughput, and improving customer satisfaction. And it's that last one, the improving customer satisfaction, that I think is perhaps the most crucial, especially given, frankly, the poor reputation that most traditional IVR systems have in the eyes of customers. And so if you look at what impacts customer satisfaction in the smart speaker-driven world, you might expect to see having futuristic kind of feature capabilities, extremely quick responses. You might expect those kinds of things to be at the top. But in reality, and this is partly due to poor experiences that people have had over the last few years with these types of products, but also partly due to the many, many decades of extreme frustration with traditional IVRs, what matters the most to users is what we call speech recognition accuracy. Simply put, it is how well a platform understands and is able to accurately respond to users. Now, CSAT in the IVR world is a little bit more complex. There really are 5 different components that drive it. And each of these things are things that you should be thinking about and that you should be tracking. And in fact, you can use to survey your users to objectively measure your CSAT. We have at the top, we have the perception of agent knowledge. We have the promptness of a response, the clarity of the communication that's being provided, the ability to resolve problems the first time, and the ability to easily reach a human and opt out of the IVR flow if you desire. And if you think about it, each one of those different items is really directly impacted by how well your platform understands the user. If I call into my credit card company to check my balance and it keeps giving me the local branch hours instead, I'm not going to be very impressed with how knowledgeable that virtual agent is. And I won't have a solution in a short period of time. Chances are I'm not going to be able to resolve it on the first call. Imagine how much more frustrated I would be if then I try to opt out of the IVR flow by screaming, speak to a human. And it doesn't understand that either. Speech recognition accuracy really underpins so much of a user's experience with any kind of voice experience, but specifically with these virtual agents. And so it's hyper critical that you do everything in your power to get it as high and as accurate as possible. But how do you do that? Well, it's actually pretty easy. Humans, if you think about it, humans don't learn new languages by just snapping their fingers and learning them. They need training. And so too is it with your AI-driven systems. You have to take a methodical, thoughtful approach to objectively increasing your speech recognition accuracy through training. So the first step on this journey is to see how you're performing today. Let's say I'm making an IVR for a utility company. And one of the things I want my customers to be able to do is report problems, power outages, down power lines, brownouts, things like that. The first step is to figure out what part of the conversational model you want to test, really what that most important part is for this individual step. And then from that, you need to identify realistic variations on phrasing that your real customers might say. I might, you could come up with these on your own. A lot of that is pretty easy to come up with. You might be able to pull historical call records from your existing legacy system and see what real users have said before. Or we even see people using fancy text generators like GPT-3 to come up with these. So if I were trying to report an outage, I might say things like, I want to report an outage, my power isn't working, the lights are down, I need to talk to somebody about why my power is out. Then you need to really understand the vocal profiles of your real users. You want to make sure that you're not just testing with your own voice and your own accent, that you're testing with those of the actual people who are ultimately going to be using and impacted by the system. Once you figure that out, you want to take those utterances, take those combinations of voices, and send them to the voice platform. And some companies try and do this manually, which is pretty painful, and it's not repeatable, it's not reliable, it's typically not representative of the varied voices of your real users. The leading organizations leverage Bespoken. We take an approach via automation that enables us to send audio either generated with text-to-speech tools like Amazon Polly or Google Cloud Text-to-Speech, or even automatically send real human audio, audio that you might have sourced, again, from your production system or captured by a partnership with a crowdsourcing company. with manual testing, if you try to do it, you can write a test once, and then every time you execute it, it's still going to take the same painful amount of time to get back the results. With automation, you can write a test once and really just execute it forever at the click of a button. That's especially helpful. I mean, in this case, I've got 4 different utterances there, so that's not so many. But to really get a statistically significant picture of how this AI system is doing, we're typically sending thousands, sometimes even tens of thousands of combinations of utterances to the platform. So embracing some kind of automation solution for this really pays significant dividends. The next step is to analyze the results. So in this first example, here I used just that first utterance. I want to report an outage, and I used a U.S. English male voice, and lo and behold, it worked. No big surprise there. All of the most of the modern voice systems do pretty well with plain Jane U.S. English voices, and that's a pretty simple utterance. The second one that I did, I used a U.S. English female voice. That one worked pretty well too. Again, no big surprise. What about that third one? I said in this case, I want to report an outage. I used a Mexican Spanish male voice, and it didn't match up to the intent I was trying to test. It didn't match up to report an issue. It matched up to one for a repair request. That example, that type of error, a homophone error like that, is incredibly common, and you'll find it a lot, especially when you first start out in this tuning process. And fortunately, it's really easy to fix. All you have to do is add repair in as a synonym for report for that particular kind of utterance. The next example, my lights aren't working. It didn't match to anything. And that then to me is an indication that I forgot to add similar types of phrases into my conversational model. And again, that's still a pretty easy fix. What about the next one? The next one, I still matched to the wrong intent, matched to an emergency intent. And, that to me means that I had too narrowly defined the utterances that I put in that conversational model for either report an issue or for that emergency intent. I said the power is down, and it heard power and down, and routed that thinking that I was reporting a down power line. Again, something that might be a little bit more complex to try and root out what the fix is, but very clear to identify, exactly where the error is. Now look at that last one though. That one's an interesting one. I said I want to talk to someone about my power being out, and it routed me to an agent. And so that's not necessarily a bug, right? The user did say they want to talk to someone after all. But going back to those CSAT drivers that we talked about earlier, resolving problems the first time, quickly providing responses, as well as the drivers for IVR modernization efforts for companies, reducing cost, increasing call center deflection. That to me is something that probably could just have been handled by the virtual agent. Now that was a pretty simple example, and perhaps it's not that applicable to many of the participants out there today, but there are a number of classically difficult types of input that unfortunately also happen to be some of the most common ones that you might be requesting in an IVR flow. Take, for example, a simple address. There are lots of different ways. If this is my address, there are lots of different ways I could pronounce that address. If I say 123 27th Ave, 123 27th Ave, does that mean this way of writing out the address? Or does it mean 123 27th Ave? Similarly, if I say 123 27th Avenue, does that mean what I intended it to mean? Does it mean 100 23 27th Avenue? Or does it mean 120 327th Avenue? Same with the last one. 123 27th, lots of different potential combinations that could be. We see issues like that, quite frequently, and they are extremely difficult to try and correct if you're going off anecdotal evidence. They are much easier to try and correct if you have objective and statistically significant evidence to be able to use to refine your models. So now once we have those, once we've made changes, once we've introduced some fixes, perhaps, we need to repeat that process. These systems are AI driven. That removes a lot of the burden from us as developers and designers, but it also means that, anytime you introduce non-deterministic changes, you get potentially some unpredictable results. And so anytime you make even a very minor change, even if you think that, oh, there's no way it's going to have some kind of downstream impact, you want to rerun these tests again and measure that baseline. Sometimes you'll find that you were trending upwards and upwards and upwards, and then you had a slight setback that you actually reduced the accuracy of your system. And that's okay. Again, the only way to know that you haven't introduced an unintended negative consequence, the only way to know what that impact was and measure that impact is through repeated objective testing. And so, taking it a step further, we see the approach to voice app quality as a continuous process that really has 4 primary tasks: gathering, collecting either real world or generated audio that's representative of your real users and their real use cases; testing, measuring how well your system performs versus how it was actually designed; training, taking the information that you have found from doing the testing and modifying your system to ensure that it better performs in real world conditions; and then ultimately monitoring to be able to see not just how is it performing today, but how's it going to perform tomorrow? How's it going to perform 6 months in the future? And that process may seem like it's very complex. It may seem like it takes a long time, and it is an endless journey towards delighting your users and optimal quality. But it doesn't have to take a long time. It doesn't have to be that complex. We did earlier this year. We did a really exciting project with a company called Epcor. Epcor is a large Canadian utility company based out of Edmonton. They provide utilities to nearly 400,000 people in the Edmonton area. And so, wanting to be better prepared heading into the long, cold Canadian winter, they undertook a significant modernization effort for their power outage reporting system. And we worked together to try and make sure it was going to be as successful as possible. So they had a bunch of challenges. And some of these may be familiar to the people out in the crowd. They had a tight timeline, very small team, no prior experience with IVR modernization, and a slew of challenging addresses, over 40,000 unique addresses that they had to tackle. So we worked with them to implement end-to-end tests, end-to-end functional tests, which reduced the need for manual testing by over 90% and found several significant critical bugs, found them well before they got out into production. We worked with them on running multiple training sessions, both an initial baseline and then repeated follow-up sessions, which reduced the number of errors from poor speech recognition by almost 50%. And think about that. That is a drastic reduction in user frustration, drastic increase in their satisfaction with a virtual agent. We also then identified, some significant bottlenecks in their system, which, regardless of it performing admirably, regardless of it understanding the user, limited how many users they could address in a given period of time. We're able to increase the max throughput of this system about 6-fold, and that obviously lets them provide much greater care to their very large customer base. It also means that they can reduce the number of human call center operators that they need to still be able to appropriately support that customer base. The improvements that we got with Epcor were really significant, but that's not to say that they're not uncommon or not representative of what many organizations could see with an approach like this. Really, if you follow an iterative process like this that we've laid out, you too can reap those benefits in your own organization and with your own modernization efforts. Now, the approach that I described, works great once you have a conversation design or perhaps, an existing legacy system that you're migrating over to a modern system. But what if you're very early in the design and development phase? And what if, like many teams out there, your team has never led an IVR modernization effort before? Well, for more on that, I'd like to introduce Maddie from Rasa, who can teach us about some of the best practices for designing and optimizing your voice development lifecycle through conversation-driven development.
Awesome. Thanks, Emerson. Great. There we go. Yeah, Emerson, thank you. That was great. Hi, everyone. I'm Maddie from Rasa. So today I want to talk about, some of the things that you want to think about when you're building production-grade AI assistants and how to use Rasa to build an IVR system or a voice-powered AI assistant. So if you've built an AI system before, you'll know that it's hard to build a good one, right? It's easy enough to build something like a prototype or a simple chatbot that you can stand up in a couple of hours, but to actually ship something that helps users and that delivers value, that can be quite difficult. POCs don't necessarily uncover the hard challenges, going to production does. And, the way that you build a really good AI assistant is you need great research. You need great models for both NLU and dialogue. And just like with any other software application, conversational AI isn't that much different. You need engineering best practices. So it's not enough to have, the most accurate or performant model. You also need solid engineering principles like CI/CD or integrated version control, or a microservices architecture, like maybe using Kubernetes or Docker, if that makes sense for your use case, right? And one of the cool things about conversational AI is that users will literally tell you what they want, right? They'll ask the assistant something in a way that you haven't trained before, or they'll tell you if your answer is wrong or irrelevant. So listening to users and using those insights to improve your assistant and automating that process is conversation-driven development. And this practice is an effective way to build those robust and resilient assistants that work in production. So we'll talk a little bit about this. And I also want to say that, I think Emerson touched upon this, but we're still kind of in the early stages of conversational AI, right? Even though that this is something that's been around since the 1960s, we're still early in building something that everyone can use. So in order to accomplish this, we really need to find a way to bring everyone into this community so that we can contribute in a meaningful way. And that's our mission really at Rasa, is to empower everyone to both build and use conversational AI. So Rasa builds a standard infrastructure layer for conversational AI. So as a data scientist or a developer, you'd use Rasa to build robust contextual assistants that go beyond just answering FAQs and really engage in multi-turn, naturally sounding, end-to-end interactions. And the way we do that is by building open source models and infrastructure, and championing other open source tools as well. We have a great community that's nearly 10,000 members strong, and we support them. We also have a research team that ships applied research directly into the product so that it works reliably when you use it. And we're really blown away by the support that the community has shown us, developers from all over the world using Rasa. So feel free to check out our showcase page. There's some really great examples there, and some videos that show you how companies and people and teams are building or maintaining conversational AI applications in production. And you can also take a look to see how conversational AI is being leveraged in the real world. So on a high level, right, here's where Rasa really fits in your stack. Rasa is a customizable infrastructure that provides conversational AI building blocks in a plug-and-play architecture. So every conversational AI application is made of several distinct layers, whether you're using Rasa or not, right? You have the computation layer, which has programming languages or machine learning frameworks. And then you have the conversational AI infrastructure layer, where you can have something like Rasa. And then you have the tools and services layer that sits a level above that. And this can be Rasa X, which is a browser-based tool set for those of you that are familiar. And you can use that to really test, train, and improve your conversational AI applications. You can have other tools and services at this layer as well. And then you have the application layer. That's where your application resides. So it can live alongside other systems and web application. So for example, if you're building an enterprise help desk assistant, right, and enterprises' payroll or HR or IT systems can live here. And depending on what your AI assistant does, it might interact with one or more of these systems. You know, if you're help desk assistant, if you're calling in to check the status of a ticket, or if you're calling in to know when your next paycheck is going to be deposited, then it would need to talk with other payroll and HR systems. And at this layer, you also have user interfaces that users will actually see and interact with, right? So let's say, and the reason I have this slide is, let's say you're making a pizza. And if you know how to make pizza, you'd know that you need raw ingredients for the dough, you need cheese, sauce, toppings, and so forth, right? And typically you have three options. You could make all of the ingredients yourselves. You could customize prepared ingredients and put all of the components together to make the pizza. Or you can buy a pizza with everything pre-built and pre-chosen that you can't customize. So just like you don't write your own programming language, I mean, you could, or just like you don't write your own machine learning framework, you don't create one from scratch, although you could. You don't have to build everything from scratch, and you can extend these tools, you can customize them and transform them to fit your specific use case, and spend more of your time customizing, you know, all of these things to your needs and making iterative improvements so that it scales in production. And I want to bring us back to the slide that Emerson went through, right? You can use Twilio or Vicinity or any telephony agent. So what you would do to integrate that agent with Rasa is that first start by creating an account after you've identified the agent that you want to use. In this case, it's Twilio, so you'd need to create a Twilio account. You configure your Rasa webhook with Twilio, and you would update your credentials.yaml file within your Rasa project file to configure the voice channel. And the Twilio agent will be responsible for converting speech to text or text to speech. And once that text is posted to Rasa via the configured webhook, Rasa's NLU will process that text. It's going to identify the intents and extract the entities. And then dialogue management decides, you know, the next step, which could be calling a custom action. So like calling a database or calling an external API or responding to the user with a message. So Rasa would then send that message back to the telephony agent, which is then delivered to the user. So if you want to check out exactly how to do this, or, you know, more in-depth view of how Rasa works, you might want to check out our beginners course that will walk you through how to build resilient AI systems. And in addition to some of the examples that Emerson went through, our clients and community have been building IVR systems for work and for personal projects, right? And one of the examples that I really like to talk about is this really cool Make AI voice assistant. And it's a good example of a modern IVR system that automates certain parts of the drive-through operation. It uses Rasa and Vicinity. And the integration here isn't that much different from using Twilio. So you would simply need to configure the Rasa webhook with Vicinity and then update your Rasa files so that it knows to talk to this voice channel. And the assistant here can greet customers and it can take their order. It's also equipped to handle corrections. So for instance, if you were to change your mind and say you wanted fries with your order, right? The assistant can handle that. Or if you were to switch context, and if you went from going to, you know, ordering, you know, fries and burger to asking what kind of pies they had or something like that, it can handle that context switch. And so, you know, the point is that it's important to review conversations that users are having with your assistant so that you can see where your assistant went wrong or how your assistant can do even better by proactively helping the customer and generally improving the experience overall, right? And we'll talk more about how to do this with conversation-driven development. Another example, another really interesting project rather, that uses IVR, and in this case, Twilio, is this assistant can book salon appointments via phone and allowing businesses to automate or deflect a portion of their customer service requests to this assistant that can do all of the scheduling and the booking, you know, leaving more time for businesses to spend on tasks that actually need human intervention. So let's take a quick look at this assistant. It's also on our showcase page for those of you that want to take a look.
for you?
You should
I'd like
be
to
able
schedule
hear
an
that.
appointment for
But let me know in the chat if you're not able to, or if there are any questions. I'll take a look at them as we're taking a listen to this assistant.
Hi, I'm Spoil Me Salon's automated assistant. What can I do for you?
I'd like to schedule an appointment for tomorrow.
What would you like to come in for?
A beard trim.
Can you do tomorrow at 9 a.m.? I have an opening then for a beard trim.
What are your business hours?
We're open 7 days a week from 9 a.m. until 5 p.m.
What about Sunday instead?
So as you may have noticed, the person there actually kind of switched context and went from confirming their appointment to asking a question. The assistant was able to answer their question, and then they went back to scheduling their appointment. So this is, this is a way that most users typically talk, right? You might have questions or you might change your mind. So it's important to build and design an assistant that's equipped to handle stuff like that.
I have an opening for a beard trim Sunday at 3:30 p.m. Will that work?
Yeah, that'll work.
Can I get your name, please?
Josh.
Is this number ending in 4111 a good way to reach you?
Yep.
You're confirmed, Josh, for a beard trim Sunday at 3:30 p.m. Is there anything else I can do for you today?
Nope, that's it.
So right, as you saw there, right, that's another good example of a modern IVR system that's able to handle some kind of context switch, answering questions, handling sub-dialogues within a larger conversation, and then going back to the goal at hand, which was to book appointments. So some of these examples that we've just referenced and that Emerson also went through are assistants that are out there in the real world, in production. And we've kind of talked about how to do the integration on a very high level, which is just configuring your telephony agent with Rasa via webhook, and then making sure that Rasa can talk to that voice channel. So that's sort of how it works on a high level, but it takes more than just integrating a bot to work in production and to actually help users. And when we create training data for your assistant, we do it by coming up with training examples. We list all of the things that we think users might say, and then come up with a few different ways that they might phrase it, right? And that's a fine way to start, but it doesn't necessarily reflect production or real users. Because we know, as developers of this bot or as teams that built conversational AI applications, we know this bot so well that it's actually really hard for us to imagine how a user that doesn't know anything about it might use it. And even though we try to break it, it's still going to be within the confines of this knowledge. Also, we're just getting one person's or one team's perspective. If we train the assistant based on just how we talk to the assistant or how we think users will talk to the assistant, chances are that the assistant won't perform very well when it encounters others. And that's mostly because we can't anticipate all of the different ways that users interact with your assistant. We can't anticipate all of the different ways that people talk and interact and how they could go from dialogue to sub-dialogue to context switch to fallback and so forth, right? So the solution is to train your bot with data from real-world conversations and not with training data made up by a developer. And the guiding principle overall is to help your assistant adapt to what the user wants rather than expecting the user to adapt to your bot's behavior. But the challenge still kind of remains. It's easy for us to say, well, train it with real world data. This is how you're supposed to improve it. But how do you actually improve your assistant with it? And so we came up with a way to do just that. And we use this term conversation-driven development to describe the process and the principles behind gathering and using real world data to make your assistant better. And there's 6 steps involved in conversation-driven development, as you can see, which is share, review, annotate, test, track, and fix. And Rasa X, which is a browser-based tool set, which you may have used, allows you to do conversation-driven development. CDD, though, is framework and tool set agnostic. So these are really best practices and principles you can use regardless of the framework and technology that you use. So, what's the alternative to practicing CDD, right? It's to develop your system for months in isolation before testing it with users, where, you might have spent a whole lot of time looking at metrics and optimizing for situations that may not happen in production. For example, one of the things that we often get asked about is sentiment analysis. Using sentiment analysis during the first month of your system being in production isn't that important as, compared to, say, collecting feedback via maybe a thumbs up emoji, right? And making improvements based on user feedback, or even focusing on things like mishandled intents and correcting them. So try to prioritize what's important to your use case. Each use case is very, different. And then those high level metrics may not be super important within the first few weeks. The opposite of conversation-driven development is also maybe auto-generating training data that doesn't reflect what users actually say in production, or pushing things to production without running tests. Conversational AI isn't that much different from software development. With most software application development, you will definitely write tests. So try to do the same thing with conversational AI, write unit tests, functional tests, end-to-end tests for both your NLU and for dialogue. So this is the opposite of what CDD is, but let's talk about each of the steps that we've outlined, right? One of the first things and most important parts of conversation-driven development is right when it starts, which is as early as possible in the prototype phase. When you're first building and first developing an AI assistant, it's definitely understandable and common to not have any real conversations yet, because you haven't tested it with users yet, right? So you use that developer generated data to build your training data set, and that's a fine way to start. But you also want to talk to subject matter experts. You want to consult FAQ articles and knowledge bases and try to figure out what your users will ask. So if you're building a help desk assistant, it might make sense to look at the most commonly asked questions. Look at IVR, call data and stuff like that, ticket data, and then see what's most popular and try to get the assistant to handle those scenarios first, right? And based on that, you can come up with enough training examples to help you get started and to build that prototype assistant. But once you clear that first stage of development, it becomes really critical that you start to test your assistant with real live people. And you can use this data as you keep collecting these conversations to build your training data set. And these examples are going to more accurately reflect what users will continue to say. Second thing you want to do is review. Collecting data isn't really enough. You actually have to take time to read through conversations that people have with your assistant. And this is something that's actually helpful at every stage of the project, right? From prototype to production. You could be in production, you could be continuing to maintain your application, but you want to review conversations on a frequent basis. So maybe, set some good practices around trying to review conversations each week, or every other week or every other day, or whatever works for you. Too many teams get caught up with looking at exclusively at metrics, like what % of my users are expressing intent X, and that's not super helpful immediately, right? But reviewing what users say can be super important. The next thing you want to do is annotate. So improve your NLU model based on messages coming in from users based on real conversations. So when you're building a POC, you can come up with examples yourselves. You could generate hypothetical conversations, end-to-end scenarios, and synthetic examples that'll help you get started. So it's a great way to bootstrap your chatbot. Just like rules and if-else statements can be a great way to bootstrap your chatbot, but you eventually want to move away from that and use data and machine learning to predict the next best action or something like that. Just make sure that less than 10% of your data set should be synthetic when you actually go to production. So you want to be annotating data and then turning those real messages into training examples or stories. And of course, the next natural thing to do is after you've annotated all of the data, you want to be able to test it. So use whole conversations, like end-to-end conversations, as tests for your assistant. Professional teams don't necessarily ship applications without tests. So any kind of modern IVR system or conversational AI application should be the same, which is you should be writing tests before you go to production. And then after you've done that, track what's happening in production, right? So come up with a way to identify successful conversations. And looking at, your bot successfully answering a question is helpful, but look beyond that, right? Also look at actions and other ways, other proxy measures to identify successful conversations. So maybe it makes sense to look at an action that the user has taken, like signing up for your service, or maybe the user didn't take a particular action, like maybe they didn't get back in touch with support within 24 hours. Like, what are these proxy measures telling you about how your assistant is doing? So use that data to tag and filter conversations to understand what's working and what's not working. If users, click on something and then answer a question or tell your bot that they're not being, accurate in their answer, that's also like a good way to track what's working and what's not working. And of course, like the next step is to fix stuff, right? So study conversations that went smoothly and take a look at ones that haven't gone that smoothly or ones that totally failed. And successful conversations can become tests right away. And you can use end-to-end conversations as tests. And, unsuccessful conversations tell you a lot too. That's really valuable data too. So they show you where you might need more training data or where you might need to fix an answer. So track the different ways that your system fails so you know that you're reducing failures over time. So as you may have guessed when we were walking through each of these steps, is that CDD is a user-centric approach to building AI systems, and it requires more than just software skills. It's also not a linear process. You'll find yourself jumping between all of these actions. You can review at every stage of this process, like we've talked about. You go from testing to fixing, and then after you fix something, you want to go back and test it, and you want to go back to annotate it and handle any kind of mishandled intents and something like that. So CDD is also, a practice that you can implement, like we talked about, regardless of the framework that you use. But Rasa X is a tool that makes it easier for you to do CDD, and here's how. I want to quickly take you through. I'm just going to make sure to see if there's any questions. Hey, Dishant, I think I recognize you from our community. I think you're also a Rasa superhero, so thanks for joining. Is the content going to be the same as Udemy's Rasa workshop for certification? If you could just clarify which content you're talking about, that'd be great. But in this webinar, we're mostly going to talk about CDD and then how to use, at least from the Rasa side, how to use Rasa X to do CDD. Okay, so Rasa X, you should be able to see my screen here, is a browser-based tool set. Where you could review conversations, you could test stuff, you can train, deploy conversational AI applications to, and really maintain your applications in production. So the first thing that you'll see when you deploy your assistant to Rasa X, actually you can install Rasa X on your local machine when you're still testing, but eventually, right, you'll want to move your project to a server, especially before going to production. So what you see here is the share your bot link. What this does is that it generates a link that I can then send to anyone. I can send it to friends, colleagues, clients, and then have them talk to my assistant and try it out. When someone clicks the link, they see a very simple chat UI. They're not going to see what you see on my screen here. They'll just see the chat UI. And that's a really great way to test your assistant early on, because it gives users a realistic looking chat interface to talk to without, you don't have to go through the process of connecting to a messaging channel if you just want to, test with some test users. You also don't have to get your users to use the command line to talk to your bot, right? So this is a good way to share your assistant early on and get them to talk to your assistant. And what you'll then see as users talk to your bot is conversations that people have with the users that you may have shared it with. So all of these are just conversations that people have had with, this financial assistant that we've built and deployed. And what you can do under conversations is use all of these filters to narrow down a subset of conversations that I want to look at. So for instance, if I only want to look at, conversations with a particular intent, or if I want to see conversations where a user asked to check their credit card balance, or if I want to search via channel or something like that. These are all filters that can be really useful to narrow down conversations. You can also filter by confidence. For instance, if I'm trying to fix, if my bot's not that accurate and I want to filter by confidence, right? I can take a look at the intent confidence and say, I want to look at everything below 0.5 or 0.4, and then use that to, correct any mishandled or incorrect intents or something like that. The other thing I can do in the conversations tab is I can select these conversations to create new story data for my bot. So let's say I see an interesting conversation where, a user jumped into a bunch of sub dialogues and I don't have that in my story or my training data file just yet. So I can copy this over, copy this to interactive learning, and then save it directly to my stories file and continue to add training data that way. So it's a very easy way to collect conversations, review them, and then just add it to your training data, right? The next thing that I can do is annotate, right? That's the next step in conversation-driven development. Every user message that comes in goes to this NLU inbox for processing. And that's where you can annotate and save messages as new NLU examples. So here, you can see which intent the model predicted and which entities it extracted, right? And then you can make corrections right here. If everything looks correct, I'm just going to go ahead and save the message. But if it didn't, so what about my new credit card? Maybe that's not the check balance intent, right? Maybe the check balance intent has to do with checking your account balance, and maybe you're trying to order a new credit card. So this might be wrong, right? So you would go to your list of intents if you already have an intent for that. If you don't, you can create a new intent, add that, save it, and then, there's a big train button right here that you can use to train your models. So the next step would be to push your new training data to Git. And RasaX connects to your remote Git repository using a feature called integrated version control. You might be familiar with that. And that creates a continuous workflow for making updates to your assistant. So you can go all the way, from annotating new messages that come in to saving those changes in Git, to training a new model, and then kicking off any kind of automated test that you have when you're ready to save and send those changes to production. So this is, a really continuous and iterative process that allows you to collect conversations, that allows you to review them, annotate them, add these conversations to your training data, to your stories.md file, and fix them and so forth, right? So go ahead and download RasaX and give that a go if you're interested. And you can build, you can use, one of the starter packs that we have and build on top of it, or you can do your own thing and add more features. And definitely let us know if you do something new, because we're definitely interested to see what our community is up to. So over time, basically, CDD will help your assistant adapt to what the user wants, rather than expecting the user to adapt to what your assistant does and adapting to your bot's behavior. It's this continuous improvement framework that's technology and tech stack agnostic. It's a set of principles that maintain your assistant in production so you can deliver something that has measurable value and something that actually helps your users. So I'll stop there, and I think Emerson and I are ready to take questions now.
Yeah, great job, Maddie. Thank you very much. We have just a few minutes left, so if anyone has any questions, please send them into the chat here, and we'll try and address them. I see John Kelvey had submitted a question. He says, Maddie and Emerson, what do you think is the best way or ways to do real-world training for voice systems? Maddie, would you like to start?
Oh, yeah, sure. So, I mean, I think voice systems are very similar to actual chatbots too, right? In that if it's voice systems, you're collecting all of those conversations, you're recording them, and then you can process all of that speech to text, and then you do the same thing, you know, give your team an opportunity to review these conversations, and then follow the process of CDD to review, you know, track any changes that you're making, annotate the data. You know, for instance, if you see anything interesting in your call log data that tells you, you know, different ways to identify a particular intent or different sub-dialogues and stories that you want to add to your assistant, maybe new capabilities that you want to handle, you know, real world data is very useful for stuff like that. So continue to do that. Yeah, and then test and fix iteratively. Emerson, did you want to add to that, or?
Yeah, sure. Just you know, on top of that, it's I think it's critical to really understand the particular use case that you have. So you know, the types of training that I'm going to need to do, types of testing that I'm going to need to do, and the real world audio and how to combine that with some generated audio is going to be very different if I'm making a new smartphone versus I'm integrating voice into an automobile, or I'm doing some kind of connected hearable device. So having a mechanism to really understand what that use case is, and then you know, knowing what type of audio can you capture using that the automobile example, you know, capturing acoustic interference, capturing background noise at in an actual vehicle at different speeds, windows up, windows down, people talking in the background. You know, finding ways to minimize the amount of real world effort that you have to go through, but then maximize that by overlaying it on top of generated audio, perhaps, you know, really makes it so that you can be a lot more effective and have greater scale at lower cost than if you were trying to do everything manually.
Yeah, that's a good point. That just reminded me, I think it's also important to like train in different accents too, right? Because I mean, with chatbots, you don't necessarily have accents. Maybe you have like slang and things that you want to be able to pick up, like regional or otherwise. But with voice systems, you also want to be able to train in different accents so that it's accessible and, you know, inclusive.
And Bhavin has a question. Is it possible to train a particular person's voice and then it'll give only an answer, like a personalization? It is possible to do that. You know, I think there are some really fascinating use cases that people have where they're building customized voice assistants for people with physical disabilities, where their speech might not be intelligible to the human ear, but it's very, very clearly intelligible to some of these NLP systems. Those are very, very specific use cases, though. You know, in many other cases, besides things like voice matching, which the current smart speaker voice assistants support, you know, not too many organizations' use cases are really working on hyper focusing on perfectly training for each individual user, more kind of targeting the broader swath of users. And I see we are at the top of the hour, so I want to thank everybody for joining today. This has been really, really exciting. We will follow up with copy of the presentation here. We'll also follow up. We're doing something special for any attendees of the webinar. So if you are working on a modern IVR system, if you're still wondering, you know, how can you apply these principles that we've discussed, how can you apply some of these learnings and techniques, not just broadly to IVRs in general, but specific to your system, stay tuned for the follow-up email. I think you will be pleasantly surprised what we have in store for you. Thank you again, everyone. Have a great rest of your day, and thanks for joining.
Thanks, everyone.